Hi viewers, welcome to LMS Solution. Today we are going to see about fuel cell battery driven electric vehicle in MATLAB. This is simulation model we developed for fuel cell battery driven electric vehicle in MATLAB. Here you can see that this is a fuel cell. Here we are using fuel cell and the rating is the 24 volt 24 volt fuel cell with the rating of 1.26 kilowatt. And here you will see that the cap fuel cell parameter here, and then here you will see that the nominal operating point and the maximum operating point. Here you will see that the nominal operating voltage will be 24.23 volt, and then the current at nominal operating point will be 52 amps, and then maximum operating point voltage will be 20 volt, and then current will be 100 amps. That means 20 into 200. Here you can see that 20 into 100, which is equal to 2000. Maximum power it can generate around 2000 watts. Nominal power will be 1.26 kilowatt. 1.26 into 1000, which is 1260 watts. And then here we are using boost converter. Here the voltage will be 24 volt, and then here we are using boost converter, and then this point will be maintained with the battery voltage level. Here you can see the battery voltage we are having 48 volt. We are connecting that in the output of this boost converter on this battery. So the voltage will be maintained at 48 volt. Rated capacity will be 200 Ah. And this boost converter, right, going to be controlled by means of MPPT algorithm. Here we are using MPPT algorithm to extract the maximum power from the fuel cell. We need to drive that electric vehicle as well as to charge the battery. For that, here we are measuring the fuel cell parameter, and then here we are taking voltage and current of the fuel cell. That going to be processed via P&O MPPT. Here we have that P&O MPPT. Here we are fixing 4 parameter: initial duty cycle, maximum duty cycle, minimum duty cycle, and then small change in duty cycle. And then you have to calculate power of PV, change in voltage, change in power. Based upon that change in voltage, change in power, you have to calculate whether it is less than 0 or greater than 0, that change in voltage or change in power. So you have to increment, decrement the duty cycle, and this code will be keep on execute every sample time in order to calculate the duty cycle. Next process, after calculating the duty cycle, here the duty cycle will be processed via PWM generator. That means the duty cycle, we will get the duty cycle. This is a duty cycle. It's going to be compared with the triangular wave. When it is going to be compared with the triangular wave, it will be generate the pulse. It will be generate the PWM pulse. So this PWM pulse going to be used for control this MOSFET. Not the boost the voltage from 24 volt to 48 volt and extract the maximum power from the fuel cell. Next thing is in the common point. Here you are connecting that electric vehicle. This is going to act as that electric motor, that BLDC motor. This will be act as a electric vehicle. Here we have converter or voltage source inverter that going to act as a electronic commutator for BLDC motor. Here you have BLDC motor. So this BLDC motor going to be here going to measure the Hall sensor output. Hall sensor going to be converted into back EMF based upon this control logic. Here we have table for Hall sensor and then truth table for a back EMF. This Hall sensor going to be converted to back EMF based upon this AND logic. You have to apply AND logic, and then finally after applying AND logic, just you have to use some logic for generating the back EMF. After generating the back EMF, next you need to generate the control pulse for that or switching pulse for that electronic commutator or voltage source inverter. So this is a truth table for generating switching signal, switching pulse for the voltage source inverter based upon the back EMF. Here you will see that based upon this back EMF detail, and the back EMF going to be compared with the 0, greater than 0, less than 0. Each phase of the back EMF will be compared with the greater than, less than 0. Based upon that, we are getting the switching pulse Q1, Q2, Q3, Q4, Q5 and Q6. This is going to be used for control this voltage source inverter to control this BLDC motor. Based upon that, you will get it will be ran and some constant speed or varying speed according with our application for electric vehicle. Here it will be maintained at some constant speed only. So next I am going to explain the operation of the system, that means simulation result. Here you can measure the fuel cell voltage, current and power, and here you can measure the battery voltage, current and SOC of the battery, and then Here you can measure the speed, and then here you can measure the torque, and also you can measure the back EMF and the stator current of the BLDC motor. And then here we have some conditions up to 4 seconds that pressure of fuel, that means fuel pressure and air pressure will be 1 bar. After 4 seconds we are changed to 0.5, and then you have to check the result. And also when there is no fuel pressure, then you have to check the responsive system, and we have to show that result also. We will explain that concept also. Now I am to simulate this model. Here we are making fuel cell pressure from 1 Newton, then 1 atmosphere pressure to 0.5 atm. Now we can see that fuel power is extracted towards 2000 watts, because at 1 atm, right, it will be generate maximum power around 2000 watts. Here you will see that the fuel cell voltage will be 20 volt and current will be 100 amps. Here you will see that this is battery voltage and this is battery current, and this is stator current of the BLDC motor. EMF, this is rotor speed, and this is electromagnetic torque of the BLDC motor. When the time reach to 4 seconds, that fuel cell pressure will be changed from 1 atm to 0.5 atm. Here you will see that because of change in the pressure of fuel and air, here that power is generation will be reduced in the fuel cell according with the charging current of the battery also change. Now I am going to make that pressure of the fuel cell equal to 0, and then you have to check the result. Now you can see that you will see the difference. Now here you can see here that because of change in pressure is comes to around 0. This power is not enough to drive that vehicle. During that time, what happens? The battery is changed from charging mode to discharging mode. Now the current will be changed from negative to positive. Positive means is in the discharging mode. Negative means charging mode. Here you will see the jump in battery current from this point to this point because of the fuel cell pressure is changed to 0 atm. And also here you will see that the battery SOC is keep on increasing up to this point. After this point, here we change that fuel pressure to 0. The battery need to supply power to that drive that load, that electric motor. That way the SOC is keep on decreasing here. But here you will see that rotor speed maintained constant, the torque of the electromagnetic torque of the machine is maintained constant, and stator current must maintain constant without any deviation. So in this system, the fuel battery will be balance the power supply. That means when there is no power in the fuel cell, battery will be comes to drive the motor. When fuel cell having power, it going to drive the electric motor and charge the battery in the electric vehicle. This is the operation of fuel cell battery based electric vehicle concept in the MATLAB. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.